All right, so I just wanted to do a couple more of these example problems so you guys can feel real comfortable with this. So basically, when we're asked to solve a polynomial, and we've got some simple polynomials, we're just doing third-degree polynomials on the test. But this same process works if you have a fifth-degree polynomial, a seventh-degree polynomial. But essentially, what you do is you start off with something that looks like this, you know, like x to the fifth plus x to the fourth plus whatever, right? All the way down to some number at the end. Then what we do is we divide that polynomial. And then step 3 would be is you divide until you get x plus a number, we'll just say a, times x plus another number, we'll just call it b, that's an x, maybe. And you just keep doing it until at some point, you'll say x plus c, at some point you'll get a quadratic. And you guys know how to factor quadratics, so you'll get something like ax squared plus bx plus c. And then once you get to that point, these are all factors, right? These are all factors of this bigger polynomial in step 1. And then eventually you'll factor the quadratic too. So then the last step to find the solutions to solve, you would say x plus a equals 0 and solve, x plus b equals 0 and solve, right? And then you just do that to all the factors. And those are all the possible solutions. But if they're real solutions, in other words, it's a real number, not an imaginary number, and I heard my first hour class was not complaining, but had some concerns about imaginary numbers. If they're real numbers, then they are going to cross the x-axis, or they are what we call an x-intercept. And that just means you'll have some value for x and y equals 0. Okay, if they're real numbers. Now, we did do one example with imaginary numbers. The reason I did that is I said, look, I'm teaching you a process to find solutions. Not every solution crosses the x-axis. Right? Sometimes you guys think, oh, I just need to get x equals 2, x equals 3. No, that's not what I'm teaching you. Okay? So, but what we're doing to be nice, is when we go to do this division thing, we're going to look on our calculator. We're going to look in the graph to find one real solution. Right? Where does it cross the x-axis? So that's one thing we're being nice about, is giving you guys that little tip. Now sometimes there'll be 3 solutions when you look at the graph, but I still want you to go through and do the synthetic division because I want you to have the practice. Some of you are going to go on to pre-calculus. You'll need to know this. If you go to college, you're definitely going to do this again in college. You have to take at least one math class in college, and they're going to do this. Trust me. Okay. So I want to at least kind of prepare you for that. Anyways, with that being said, let's do that to this. So turn on your fancy calculators. Okay. I never know. Do you guys want the large display, or is it okay if I just do it like this? Because sometimes I like to do it like this so you guys can see what's on the screen. But if that is not big enough for you to see the calculator in the back, then just let me know. So we go to y equals. All right, clear that out, whatever it is. And I'm just going to enter in x, and I want you guys to do the same. You don't want to try to figure this out on the day of the test. So everybody should have a calculator in their hand, plugging this in, doing what I'm doing. Now's the time to ask questions. All right. So turn on your calculators, try to plug this in. If you don't know how to do it, you can ask me or ask your neighbor. If any one of my first semester students should know how to plug this in the calculator, okay? So then let's finish putting that in there. And then I'm just going to hit zoom standard. Now zoom standard is nice because I'm assuming that this is going to cross between x equals negative 10 and 10. Remember, zoom standard goes from negative 10 to 10 in the x direction and negative 10 to 10 in the y direction. It's option number 6. We always start there. And I look like I have 3 solutions. It looks like negative 1, 1, and 1, 2, 3, 4, 5. Okay. Now, does anybody remember how we check to see for sure? What button do I hit? Yep, trace. So I'm going to try negative 1, just for the funs of it. Remember, you got to hit negative 1, not minus 1. Yep, y equals 0. See how I did that? All right, so negative 1 works. So I'm going to over here somewhere say x equals negative 1. Now, there's a lot of stuff I've been telling you. I don't know if you're picking up on this. If this is a third-degree polynomial, then I'm probably going to have 3 solutions. Well, I'm going to have 3 solutions. Hopefully, all 3 of them are real numbers. But as we saw in, I think it was problem number 16, sometimes you have imaginary numbers. All right, so we're going to do synthetic division with negative 1. Also, remember that when we do synthetic division with negative 1, it's like we're dividing it by x plus 1, right? So it's been a couple days since we've done long division. Just remember that relationship, okay? So remember, I need a column for every power of x, x to the third, x squared, x to the first, x to the 0. I just write down the coefficients. Technically, that's 1, so it's 1x cubed minus 5x squared. Again, this is minus 1x, and then plus 5. What do I do next, guys? I'm going to drop down the 1. Negative 1 times negative 1. I'm sorry, negative 1 times 1 equals negative 1. When I add these up, I get negative 6. Negative 1 times negative 6 is a positive 6. 6 minus 1 is a positive 5. When I multiply 5 by negative 1, I get negative 5. I have a remainder of 0. Remember, because we're dividing by x to the 1 over here, this drops down a power. So this is like x squared minus 6x plus 5. Now that's the quadratic. I don't know, like, you can factor this. And so let me show you guys how to factor this. So really, right now as it stands, I want you to understand this. That we are taking this big polynomial up here, right? We're taking this big we're taking this big polynomial up here, and we are dividing it by x plus 1, and we are getting this. So just as a side note, and write this down kind of tiny over to the side, we have just figured out that x plus 1, let me zoom in a little bit. We are figuring out that x plus 1 times x squared minus 6x plus 5 gives us this thing right here. That's what we're doing, okay? That's what we've just figured out just now. Just now, that's what we figured out. We've divided this polynomial by this binomial, and we got this trinomial, which is a quadratic. Now, we're not done because I want x plus or minus 1 number, so I have to factor this. Now, you can factor this a variety of ways. I like to guess and check with the grid because these problems are always rigged up. But you can factor a quadratic however you want to. You can continue with the synthetic division if you want, or you could just factor it. Now, to factor this, and I wanted this was the main reason why I postponed the test one day, is I really wanted to take my time. My first semester students are used to factoring this way. My second semester students, maybe not so much. So I wanted to take my time and go through this. All right? So to factor this quadratic, I know that this first term, x squared, is going to end up in this box, right? In other words, I'm thinking to myself, what does this break down into? It's like something x plus a number or minus a number times x plus or minus a number. And then when I multiply that out in the grid and I combine like terms, it's supposed to equal this thing here, right? So I'm working backwards. In other words, I know this first box is going to be this x squared, and I know this last box is going to be a positive 5. So I'm going to guess what the things are. Now this is pretty easy because I know that x times x gives me x squared. So that's we're halfway done. So now the next step is, I know that this term and this term will add up to be this term. So what I need to think in my head is, what are the factors? What two numbers do I multiply to get positive 5, but when I add them up, they equal negative 6x? Yes?
6 and negative 1.
Well, okay, so I'm going to write this down. So if I say positive 6 and negative 1, and I multiply them, what's that equal?
6.
Yeah, it equals negative 6. It's a good guess, though. That's the beauty of the guess and check. You can guess something, crank through it, and be like, nope, that's not it. Let's keep going. I'll give you a clue. It has to be a positive 5, but that doesn't mean we can't use negative numbers. Anybody else want to give it a shot? What about this? Can I say negative 5 times negative 1? Yeah, if I multiply that out, it gives me a positive 5, right? By the way, if you look at the graph, where does it cross? Crosses at positive 1 and positive 5. So there's your little clue, too, right? But anyways, well, what is negative 5 times x? Negative 5x, right? What is negative 1 times x? Negative 1x. When I combine these terms, when I add those up, what do they equal? This right here, right? So then my last thing right here is going to be x minus 5 times the quantity x minus 1. Okay? So let me zoom out. So what did I just figure out? Well, I figured out that if I take x plus 1 and I multiply that by x minus 5 and I multiply that by x minus 1, that will equal my polynomial, x cubed minus 5x squared minus 1x plus 5. But remember, I'm solving that. So while we factored it, I have to go back and set each one of those factors equal to 0 to get the answers, right? So I'm going to say x plus 1 equals 0. When I subtract 1 from both sides, I get x equals negative 1. That's one solution. We already wrote that down up here. What about this one up here? I'm going to have to say x minus 5 equals 0. When I add 5 to both sides, I get x equals 5. That's another solution. Let's put that up here. X equals positive 5. Then I take this last one and I say x minus 1 equals 0. When I add 1 to both sides, I get x equals positive 1. And since we started off with the graph, isn't that where it crosses? Yeah, let's double check. So if I hit trace and I plug in 5, guess what? Boom, y equals 0. If I plug in 1, guess what? Boom, y equals 0. So all three of those are solutions. I'm going to take a screenshot of that and try to figure out where to squeeze it in on this. Let's do a little bit better job. Let's put it here. So while Mr. Adams is being kind of a stickler about making sure that you guys do all the actual math, the beauty of this is the graphing calculator basically tells you the answers, right? So just kind of sketch the graph, but I also want you to plot the points because I want you to see all of the relationships. In other words, the point -1 comma 0 is a 0. This point here is 1 comma 0. That's a point. And then this point here is 5 comma 0. So that's what we're solving for, is what makes that equal 0. What value of x makes that equal 0. Okay? I'll zoom out so you can see all that. Leave that up on the... So this is our solution, is what I'm saying. This stuff right here. Okay? Are there any questions on that? How do you feel about this now? Do you feel a little better? Can you do it on Monday on the test? I see a lot of this. All right, we'll do some more, see how it goes. I'll leave that up there for a second.